we're just gonna, I'm just gonna go to a blank sheet. Okay, so number one, and there are some things that I think are really important when we do this, like, first of all, identifying the type of inequality you have. So number one is the absolute value of 3x minus 3 is less than 9. Does everyone see this on number 16? So instead of this being your homework, we're just going to do it as notes, okay? So this is what symbol? Less than. So here's how I say that. I say that this is a less than. I know it's not spelled like that, but it's a less than, meaning that my solution is going to go something like this. I'm going to shade in the middle. It's a less than. And when I write it as a comp, like when I get my solution, I'm going to be able to write it as some number is less than x is less than some number. Okay. That's what that means. If it's an and, it goes together. So this is why I gave you that blank piece of paper, just so you can show your work and have plenty of room. Okay. So we already have the absolute value all by itself on the one side of the inequality. So I have to rewrite two inequalities. So remember, with the first one, you just drop the absolute value symbols and write it as is. So my first one is 3x minus 3 is less than 9. And this is going to be an and. And the other inequality, well, in order for me to make that 9 negative, what did I have to do? Flip the sign, yeah. So 3x minus 3 is greater than negative 9. So every time you have an absolute value equation or inequality, you have to write 2 from the 1, okay? Dropping the absolute value signs requires you to write 2. So in order to get x all by itself, the first thing I'm going to do is add 3, and I just kind of do it all the way across, right? Because both sets require that I add 3 to both sides. So when I do that, I have 3x is less than 12 and 3x is greater than negative 6. So now I'm going to divide both of these inequalities by 3 on both sides. Divide by 3, divide by 3. So x is less than 4 and x is greater than negative 2. So I want you to remember what I said about when we filled out that yellow sheet, when we went through the true false things. Remember that the smallest number always has to come first. Okay, so this is the smallest numbered inequality. Would you agree with that? Okay, so I want the number to come first. I want it to start off with negative 2. So if I change the order, if I flip my inequality, if I'm going to change the order, I also have to flip the sign. So I have 2 is less than x. That's what this becomes. And then I'm just going to add to it. I'm going to merge with it the other inequality that says x is less than 4. And this is how I create an and inequality. Okay. And then we're going to graph it, just because on your test, I believe you have to identify graphs. So it might be helpful to see a graph. So remember, I said with an and, they go to the middle. So the only two numbers that I'm putting on my number line are negative 2 and positive 4. Are they going to have open circles or closed circles? Open, yeah, these are both going to have open circles because there's no bar underneath the inequality symbol. And then I just shade in the middle. This just means that x is right in between negative 2 and 4. All of the values in between negative 2 and negative 4, or sorry, negative 2 and positive 4, not including negative 2 and positive 4. Are you okay with that? Okay, let's go to number 2. So number 2 has negative times the absolute value of 21x plus 5 close my absolute value, is greater than or equal to 47. So is my absolute value sign all by itself? What's over there? A negative. And that's essentially the same thing as having a negative 1 out there. So the only way to get rid of that negative 1 out front is to divide both sides by a negative 1. So my absolute value of so the negative goes away and I have the absolute value of 21x plus 5. But when I multiply or divide by a negative, I got to do that whole flip is less than or equal to negative 47. So when is that absolute value going to be less than negative 47? When can the absolute value of anything be less than a negative number? Never, right? No solution. Okay, this is a no solution. Now, if it had started off as a negative and then when we divided both sides by a negative 1, it became like a greater than symbol. If it said it was greater than negative 47, is it possible to have an inequality greater than a negative number? Yes. Okay, because eventually it'll hit a positive. Does that make sense? Okay, let's go to number 3. So does everyone see why this is no solution? $5. Okay, number 3. Number 3 is the absolute value of x divided by 2 plus 4 is greater than 12. So I have to get that absolute value all by itself. What should I do first? Not yet. Subtract 4 first. Yeah, we undo addition or subtraction before we worry about multiply or divide. Sorry. So that's a hideous looking 4. But I'm going to subtract 4 from both sides. So now I have the absolute value of x divided by 2 is greater than 8. And now we're going to do what Connor said, which is to multiply both sides by 2. So remember that that cancels out. So I really have the absolute value of x is greater than 16. So I still have to write 2 inequalities. This is a greater than symbol. Let me tell you how I say greater. Instead of greater, I call it great or. This is a great or. So that means that x is greater than 16 or x is less than negative 16. So let's graph that and see what that means. So I have a negative 16 and I have a positive 16 on my number line. I'm going to have open circles on both. All numbers less than negative 16 is going to be shaded this way. All numbers greater than positive 16 is going to be shaded this way. So if it's an or, they go in opposite directions. Ands go together, ors go apart. That's why you need to know when you first start, should your solutions give you an or, because it's a great or when you started, or an and, because it's a less than. Does that make sense? Is that better than like looking at that yellow sheet and trying to decide what the heck it's saying? Okay. Keegan, are you osmosing everything I say through your earlobes? Okay, that's fine. Number 4. So number 4 is the absolute value of x minus 7 all over 10 is greater than or equal to 1. So this is a great or. How am I going to get the absolute value all by itself? Yeah, multiply both sides by 10. So I'm going to multiply this side by 10 over 1 so you can see the cancellation. Multiply this side by 10. So I have the absolute value of x minus 7 is greater than or equal to 10. Now I have to write 2 inequalities. My first one, I just dropped the symbols, the absolute value signs. X minus 7 is greater than or equal to 10, or x minus 7 is less than or equal to negative 10. So in order to solve this, I'm just going to add 7 on both sides, and I'm going to do that on both inequalities. Add 7 on both sides. So for the first one, I have x is greater than or equal to 17. And on the second one, I have that x is less than or equal to negative 3. If I were to graph these, I would have a closed circle at negative 3. And I'm going to shade all numbers that are less than negative 3. That's going to go in this direction. And then I'm going to have a closed circle on the 17. And x is all values bigger than 17, bigger than or equal to, right? So that's what my graph looks like. Again, ors go in opposite directions. Okay. Do you guys feel like we could divide the room up and half of you do 5, half of you do 6? Okay. So, David, pick 8 people that are going to do number 5 with you. Say their names. Say their name. Say their name. Sorry. Or point if you don't know their names. How's that? Hope. Who did you say someone after Hope? Or did you say how many people is that? Oh, and Will? Okay. You picked a little bit more than 5, but that's okay. You're good. You're good. Did you need 5 or 8? How many did I? Oh, 8. Keep going. So who did you say after Will? Eli. Zach C or Zach H? I already wrote Zach C. Who do you want? Do you want Zach H? It doesn't make me any difference. Okay. Number 5. Okay. Everybody else is doing number 6. So let's see. Eliza, you're in charge of that one. So Eliza, Mackenzie, Chris, pick your head up. Dustin. Zach. Maddie. Oh my goodness. Do I have to keep writing everybody out? You just know if you haven't been picked, right? Lainey, Connor, Erica. Are you C or K, Erica? Erica. Fallon, C, and Ella. Okay, there we go. I'm going to freeze the screen and I'm going to do them. And then we'll see what we get. You can talk amongst yourselves. You don't have to be deathly quiet. That creeps me out when you guys are that quiet. It's just eerie. Graph your solution for me too, if you would. Or at least write it as a compound inequality. We ready? Anyone ready? Anyone want me to come and look at their answers? Yeah. You did number 6? Okay. Perfect, perfect. I love it. Help everyone over here. Check them out. Is it a left hand or a great or? Left hand. So here's what happens. I find complex is greater than. That's fine.
What did you do? Yeah. And you got the building, Jeremy, you come work for. I for the news. Market. Oh, to the business. That is just so.
Yeah. But this should be 4, and this would be. And then
Oh.
and so we really have. Turn that into make. Who else? Anyone want it back?
I just checked mine, no.
You just checked yours, it was wrong. So what symbol do you have there when you start off with? So the less than, say that, less than, that means it's gotta be an and, okay, so let's talk about it. If you divide both sides by a negative, you're dividing by a negative, you gotta put that. So that'll be x is greater than or equal to -2. Here, you're also dividing by a negative, so flip it, x is less than or equal to 3. And then they'll shade the center, which is what it's supposed to do, because it's an and. All right, I'm gonna put the answers up, is that okay? So you guys can see how you did? Okay, so number 5 and number 6 are both less than symbols. So that means they are less thans. Your graph should go to the center. So remember that when you divide both sides by a negative, so I didn't show my work, I just kind of did it. But right here, when I divide by -2, you have to flip that inequality whenever you divide by a negative. So you have x is greater than or equal to -2. And then when I divide by -2 right here, x is less than or equal to 3. You have to flip the inequality when you divide by a negative. Okay? So remember, we want the negative number, the smallest number to come first. So I have to rewrite this as -2 is less than or equal to x. And x is less than or equal to 3. So I kind of smush them together. -2, 3, shade to the center, closed circles. The next one is also an and. 6x minus 9 is less than 3, and 6x minus 9 is greater than -3. Add 9 to both sides, and then divide both sides by 6. I have x is less than 2, and x is greater than 1. So rewrite that to say 1 is less than x, 1 is less than x, and then bring the other one down. X is less than 2, smush it to the center. Open circles, right in between number 1 and 2, shade in. You have a face like, I did something, or you're not understanding. Tell me what you're thinking. Good? Okay. Can we go to the last 4? Are you guys still writing this down? Still writing it? Okay. I don't know how y'all are fitting that into your teeny little boxes on your notes. Raise your hand if you still need a couple seconds to finish it. Okay, so let's go to number 7. So number 7, I have a negative outside again. So I have negative, the absolute value of x minus 19, close my absolute value, is greater than or equal to 20. So I'm going to divide both sides by -1, and I end up with the absolute value of x minus 19 is less than or equal to -20. Sir, what about what? Ooh, I didn't even see that. Sorry about that. Let's start that all over again. Let's just do that again. Sorry, guys. It's 13 minus the absolute value. I don't know why I just thought that was a problem number. X minus 19 is greater than or equal to 20. Okay, so first, I'm going to subtract 13 from both sides. Now I have negative times the absolute value of x minus 19 is greater than or equal to 7. Then I'm going to divide both sides by -1. So the absolute value of x minus 19 is less than or equal to -7. When can the absolute value of something be less than -7? Never. It can be less than, when can it be less than 0? Never. It can be greater than that, but it can't be less than that, right? So this is no solution. Let's look at number 8. So number 8, I have the absolute value of x over 4 minus 8 is greater than 9. So I'm going to add 8 to both sides first because I can't like rewrite the inequality until I get that absolute value isolated. So the absolute value of x all over 4 is greater than 17. Multiply both sides by 4. So the absolute value of x is greater than 68. So this is a great or. This is a great or. That means that x is greater than 68 or x is less than -68. You can't smash ors together. They cannot be smashed together. They go in opposite directions. So you leave it written in this form, and your graph is at -68, +68, open circles on both, and you shade in opposite directions because it's an or. So ors go opposite, ands go together. Miss Halstead, my algebra teacher, used to make us do the and or dance. She would make us require that we all wear white t-shirts and she'd make us wear her leather coat all around the room like we were Fonzie or something. It was very weird, but anyway, that's how I remember it. You have to go. So silly. We can do that if you want. Okay. Lamar, I'll bring in my bike jacket tomorrow and you can do the and or dance for us, all right? Sure, it'll be fabulous. You'll be great. I even have chaps. You can put those on. Ooh, that'd be fabulous. You look great. Bring it in. Okay. Yeah. He looked great in that. Okay, let's do number 9. Number 9, extra credit. I'll throw some extra credit in there for that. Okay, so x plus 5 in the absolute value all over 15 is less than 2. So what are you thinking? Multiply both sides by 15. So are you guys okay if I just don't show that? I just do that? Do you guys ever do that? Or do you show every single step? I mean, because I'll look at your homework and I know you don't show every single step. Well, do you understand what I did? Like, do you understand the process? Okay, just checking. So now what am I going to do? This is a less than, so this is an and. Okay. So my first one, x plus 5 is less than 30, and x plus 5 is greater than negative 30. I'm going to subtract 5 from both inequalities on both sides. So x is less than 25, and x is greater than negative 35. So because it's an and, I have to smush it together, write it as a compound inequality. So I have negative 35 is less than x is less than 25. Have you guys noticed that compound inequalities are only ever written as less than symbols? Have we figured that out yet? Less than or less than equal to. They've got to be less than, right? And when I graph it, am I going to have open circles or closed circles? Open. Shade to the middle. Okay. All right, I'm looking at number 10. Are you guys ready, or do you want me to slow down? Slow down. I have more candy canes. I brought more candy canes in from home. They were shoved in the closet by the front door. Came off the tree. Does anybody want one? I have like I should have a couple more still in the closet. Candy cane. One. Riley in the back. Eli. 1, 2, 3, 4, 5, 6. I think I have just that. 1, 2. So it might be broken. Everybody here. Did we look in the bags in Narnia? You're there. I have 4 more. Anybody else? 4 more. You already got one. So 1, 2, 3. That will give me 1 more. Who else? 1, 2. Going once. Going twice. Yeah, we already had one turd. Okay. Last time I gave you guys candy canes, though, someone dropped candy canes on the floor and I got it stuck in the bottom of my shoes. So please don't drop them all over the floor. Okay, number 10. Here we go. What do I need to do? What should I do first? Divide both sides by 19. Yeah. Divide by 19. It's 19 times. Right? The undo of times is divide. So I have the absolute value of x minus 6 is greater than or equal to 4. So this is an or, a great or. So x minus 6 is greater than or equal to 4, or x minus 6 is less than or equal to negative 4. So what should I do to everything? What? Add 6. Add 6 here, and here, and here, and here. Just do it all at once. So when I add 6 to everything, I have that x is greater than or equal to 10, or add 6, x is less than or equal to 2. So I'm going to go to my, hang on, make my number line. Remember, when it's written as an or, you cannot smush them together. You cannot combine it. So I'm going to mark 2 on my number line and 10. Close circle on both. Close circle on both. All numbers less than positive 2 goes to the left. All numbers greater than 10 goes to the right. Okay. How do we feel about that? Hang on. At 1:15, I'll put everybody on a potty break. Are we good with this? Okay, so I'm going to stop the video.